Hi, this is Kumaran. In the series of 8085 microprocessor assembly language programming, today we will discuss about 16-bit addition with carry. You know that 85 microprocessor is a 8-bit microprocessor. It will support 8-bit addition. Then only one instruction is available for 16-bit addition, which is called DAD, double addition. So with the help of double addition, we are going to perform this 16-bit addition of two numbers and with carry also. So let's start this. For example, 16-bit number means 4F C8, then D4 E9. So for example, we'll assume 16-bit number. So each digit 4-bit. So 4 into 4 16-bit numbers. So we'll add this. What you will get answer. 8 plus 9 is 17. So 17 you L divide 16. You will get 1 1. So here answer is 1, here it is 1. E plus C, E is 14, C is 12, 14 plus 12 is 26, plus 1, 27. So again you perform 27 by 16. So 116, remainder is 11, 11 is B. So answer should be B here. Then 1 here. So F plus 5, F is 15, 15 plus 5, 20, 20 is 1 4. When you divide 16, it is 1 4. So 4 here, then 1 here. D plus 5, D is 13 plus 5, 18, 18 is 1 2. So 2 here, 1 here. So this is the answer. You can perform as binary addition also. You write 16-digit binary number and practice. So already these calculations has been done in 8-bit addition. So if you want any clarification, you refer that video. So these are all the sample data, but memory, how it will be available. 4F2 C8 means it will available here. It is C8, lower byte first. So the first memory will hide C8, then next memory 4F, higher byte in 4F, likewise. The second data E9 first, then here D4. The answer also lower byte B1 first. Then we have 2 4. The carry is 0 1. That's the maximum. So this is how the memory will have data. We have to interpret like this. Okay. Let's start the programming now. For before the program, we know that we should know about the instruction DAD, double addition with register pair. Here the register pair available HL, BC, D, only 3 register pair. So for example, I am going to add with B, double addition B, which means that the HL pair plus BC pair both will be added. The answer will be updated in HL pair. Because all 8-bit operations, accumulator will hold one of the input and result will be updated. Only for this double addition, HL will act as accumulator. It will hold one of the 16-bit input and the answer also updated on HL, and flag carry flag also updated based on the result. For this result, carry flag will be 1. So what's our thing is, we have to take this number to BC register. Okay, one of the data we have to take in the BC register. So instead of BC, you can use DE also. So either BC or DE we can use. DAD D means HL plus DE, DAD B means HL plus BC. So any one of the register we have to use for carry. For the programming, we'll take that. To take the 16-bit input from memory, we'll use that LHLD, load HL pair. LHLD means get the data from the memory address LHLD 4200, which means that 2 bytes 4FC8 will be loaded on HL pair. These things we can copy to D pair. Either you can use to move instruction, otherwise you can use XCHG, which means exchange the HL pair with the DE pair. So whatever the HL pair, the first number, that should be copied to DE register. Again you take the second number LHLD 4202, we have to measure, because 8-bit means we will use continuous address, 16-bit means first data itself occupied 2 bytes. That's why we are using this one, LHLD. Now see here, this data is copied to HL. Now this data is copied to DE. Now we have to use one more register for carry. So for example, the other register is BC available. You can use B register is 0. Okay. Now we implement that DAD D, because D pair only we have the data. That's why we are using DAD. Now check the carry flag. If no carry means store or skip, anything you can use, label skip or STR or whatever it is. Now the answer is available on sum is on HL pair. The answer will be HL pair. Suppose no carry occurs means we have to increment B register to count the carry. INR B register. So everything over. Now sum is in HL pair, carry is in B register. We have to store the result from HL pair. Use that SHLD. Store the HL pair on the following address. Following address is 4204. Now the carry is on B register, that you copy to A register from B register. 8-bit transfer, use that STA. So for memory read write, we have only two options, LDA STA for 8-bit transfer, LHLD SHLD for 16-bit transfer in case of direct memory address. STA 4206. So halt, this is the program for 16-bit addition with carry. See here the label STIR, that should be here, because it should skip only that increment B register. This instruction, suppose no carry 0 means directly write 0 as carry. That's why this is the program. So that's about the logic involved in the 16-bit and programming. Let's perform the same on processor. So here the memory address, first we will write the data 4200. What data we had here, for the reference we take C8 4F. C8 4F. C8 4F E94. E9P4. That's our input. Output to initialize with 00. Okay. Now we will write the program LHLD. I think problem L in my laptop. Oh, that's why LH LD 4200. Then you exchange XCHG. Then again use that LHLD 4 4202. Then clear one of the register for count the carry. We have to use space instead of comma. So move immediate B0, then dat D register. Now you check the carry flag, jump no carry, skip. Now if no carry occurs, increment the B register for the carry. Now we have to skip label here and store the result SHLD 4204. Then we have to copy carry to A register from B register and store in the consecutive memory address 4206. Alt. This is the program for 16-bit addition. Let's compile this, no error. Let's take, see, HL pair is loaded. HL pair is loaded with the 4FC0, same like what 4FC8. Okay, 4FC8 or C8 only. Okay. Then next we exchange this. Yeah, D pair is exchanged. D pair had 0, that has been copied to HL pair. That's what exchange means, swap. Again you take the second number in HL pair D4E9. Clear the B register. Now add both. See here, when you add both, answer 4F in HL pair 24B1. What answer we had here? 24B1. That's the answer we had. Then the carry flag also 1. So here carry flag 1, so it won't skip. It will continue the next. So increment B to 1. Then it will show the answer to 4B1 carries 01. Same as what we discussed in the calculation, the same data we are getting as the output in this. So that's what about a 16-bit addition. If you have any doubt or clarification, comment on this. Thank you very much.